Okay, let's discuss slope fields. There's a few topics in differential equations that'll be covered on the AP exam, and slope fields is one of them. And a slope field is kind of a picture of a pathway that the solution to a differential equation could follow. A differential equation is just an equation that has a derivative in it. And since derivative basically means slope, what's happening here is that we have a function whose value, which is the slope, is determined by, in this case, both x and y. So what I want to do is take the x and y coordinates and use those in this calculation, and I will get the slope of the path that would be a solution to this equation. I'm not actually drawing the solution. The instructions on this question would be to sketch the slope field. I'm not going to see the actual solution. There's actually infinitely many solutions to differential equations for the same reason that when you start to integrate you have to put a plus c on the end because that constant could be anything. There are many solutions that could satisfy this differential equation, and we're just going to draw a picture of the slope that those solutions would have at particular points. Okay, so in a question like this, if the directions are to sketch the slope field, all I need to do is take the two coordinates. In this case, this point right up here is 2, 2. And I'm going to plug them into the equation, and I get negative 2 over 2, which is negative 1. So I need to sketch a little segment with a slope that's about negative 1. So it's going to look about like that, because a negative 1 is about a 45-degree angle. Isn't exactly 45-degree angle on its way down. This is going to be the case whenever x and y are the same. Negative 1 over 1, so that one here, 1, 1 is going to be the same. Now, notice this differential equation is undefined anytime y is 0. So on the x-axis, I'm not going to have any dashes because it's undefined across the x-axis. Negative 1, and negative 2, because again, negative 2 divided by negative 2 is 1, and then the negative sign makes it negative 1, and then that's a representation of the slope. So any solution that was passing through these values would, at that point, have a slope of negative 1. Now, what if x is 2 and y is 1 over here? So that would be negative 2 over 1, so that's a little bit steeper. All right, a slope of negative 2 is, just imagine a line you're graphing. It goes down 2 over 1. So I want about this level of tilt on this thing. And then let's see where else that's going to happen. When x is 2, y is 1. What about when x is 2, y is negative 1? So that's going to be 2 over negative 1 is negative 2, and then the negative sign on that one's going to make it positive. So when x is, let's see, when they're both negative, negative 2, negative 1, when I divide I get 2, but then the sign makes it negative, so here's that one. And then up here at negative 2, positive 1, again I'm going to get a negative that turns back to positive through the negative sign. So I'm going to pause here. Just try to fill in the rest and think about what these are going to look like. But for the sake of time, I'm going to pause and fill them in, and then finish it up. Okay, so here it is filled in, and you'll notice some of the segments are tilted with a slope of negative 1/2 here and here. Some of them are. Oh, excuse me, that one was positive 1/2. Negative here, positive here and here. All of the spots on the y-axis have a slope of 0 because x equals 0, and again there's nothing happening on the x-axis. So that's going to be what the slope field would look like for this differential equation. All right, so something interesting about this one is this differential equation depends only on y. So if I know the y value, I know the answer. So if y is 2, the slope would be 4. So I'm going to have a pretty steep slope of 4 at all of these places. And what I wanted to show you is, since the differential equation only depends on y, you're going to have no variation as you move left to right. because I don't care what the x-coordinate is, the slope is going to be only y squared. It's going to be positive 1 throughout here, about a 45, exactly a 45. It's going to be 0 when y is 0. It's going to be, remember that when you square your negative, you get positive again. So it's going to be positive 1 again, and then positive 4 at the bottom. And we can sort of think about the answer. If you were to solve this differential equation, you would use integration. And when you integrate something squared, you get something cubed. And when you follow this path, trying to make your slopes match, and this is just one possible sketch. It levels out and then it goes back. I appear to be tracing out something cubed, right? But look at each point. This segment at that instant is parallel to the dashes on the slope field. Another possible question is to be given the slope field and to be asked what is the differential equation that is represented here. And that's usually going to be a multiple choice, not usually something you're just going to have to create out of thin air. So let's think about this one. First thing to notice is that it is constant. It has the same slope for an x value of 2 and an x value of 1. We have no variation as you move from top to bottom. So what that means is only x determines my slope field. So answer C and answer B are immediately out because I can tell that the slope depends only on x because of this consistency moving top to bottom. Now the easiest thing in my opinion is to just pick a few points and check. So let's try negative 2, 2. The slope according to answer A would be negative x, which would be negative negative 2 or positive 2. And the slope according to D would be negative 1 over negative 2, which would be 1/2. So that little segment is either slope 2 or slope 1/2, and since it's, a slope of 1/2 would be less steep, slope of 1 would be 45. It looks to me like we have a slope of 2 here. I'm going to go with answer A. And you could double check. Another point you could have chosen was what if x is 0? Well, if x is 0 at all these points down the y-axis, I have a dash there, which means I'm not undefined. My slope is 0, so that's going to be A as well. If D were the answer, then those would all be undefined. So D is out and A is the correct answer. Okay, so I encourage you to pause and think about this one. Try to pick an answer and then resume to see if you got it. Now, I can tell on this one that the slope does depend on both x and y because on a typical y value, I have a variation, and on a typical x value, I have a variation. None of those are exactly the same all the way across. So I know it doesn't just depend on x, so C is out. So it's either x plus y, negative y over x, or x minus y. And let's talk about that 0 again. If x is 0, which means I'm on the y-axis, none of these are undefined. So I cannot have a denominator of x because then x equals 0 would be undefined. So answer B is out. So that leaves us with either x plus y or x minus y. So just pick, and you can pick some points, and let's look at this diagonal right here. When x and y are the same, I appear to be getting 0. At 2, 2, my slope is 0. So that right there is enough to tell me the answer. If 2 and 2 gives me 0, then the equation that's going to make that happen is x minus y. So these are just a couple of the ways that slope fields could show up. They're not a huge topic, but you'll probably have one question on your exam that deals with them. So it's good to know exactly what to do when you see it.